Third vectors question here during our workshop, and you can see that they're beginning to follow some kind of theme here. Part 1 of the question asks us to describe in terms of P and Q how to get from location O to location S. So we're starting here and we want to get over here. Now again, like usual, the obvious pathway is here, but we can't travel along it. So it looks like we're going to need to travel in this direction and then possibly up, or we're going to need to travel in this direction and then possibly down. What you'll hopefully have noticed is that this part of the journey, whether we're going this way or we're going this way, currently can't be made. So before we actually tackle the question that's been asked, the first thing we're going to need to talk about is this side here, point P to point Q. So the first thing I'm going to do is I'm going to talk about how I can get between P and Q, even though that hasn't formed part of the original question. So to travel from here to here, obviously we would like to do this, but we can't. So what we're going to have to do is we're going to have to go this way, and this way is denoted by the vector P, but travelling in that direction. So we're going to be going against it, so we're going to have negative P, and then we're going to be travelling with the right direction of vector Q, so plus Q. So I now can name side P to Q as minus P plus Q. So this whole side length, travelling in that direction, is minus P plus Q. That's now going to allow me to access O to S. We can go either way. We can go across and then up, or we can go up and then down. I think probably the easiest one to do is going to be up this way, which is travelling with P, so that's going to be positive P, and then it's going to be travelling down here in the correct direction of the vector we've just named, but only along half of its distance, because it said back here in the question that S was the midpoint. So we're also going to have include half of the vector minus P plus Q. So again, getting into good habits and tidying this up, we end up with P minus half of a P, because we've got half of minus P, so minus half of a P, plus half of a Q, which has come from the half of the positive Q. P minus half of a P leaves me half of a P, and I've still got the half of a Q. So our final answer to describe O to S is half P plus half Q. We then move on to part 2, and part 2 is asking us to show that RS, so point here R to point here S, so if we imagine drawing that in, we've got a line here, showing that that line there would be parallel to line OQ. And we know with our lines work, particularly on our last example, whenever we're trying to compare lines, particularly parallel lines, we know that they're going to share the same gradient. So we're looking to show gradients of these two lines. So the first thing we're going to do is we're going to talk about how to travel between R and S. And let's look back to our diagram. So to get here from R to S, I'm going to travel up here, and that's going to be travelling along half of the side of OP, which is denoted by vector P. So that's going to be half P, and it's positive because it's travelling in the right direction. And then that's going to be half of this whole vector here minus P plus Q, so it's going to be half of that, so half of minus P plus Q. Let's tidy that up. So half of a P plus half of minus P, so that becomes minus half of a P plus half of a Q, which has come from here. So I end up with half a P minus half a P. Well, that cancels down into leaving me with nothing, so I'm just actually left with half of a Q for vector RS. If we now move on to doing the other part, which is OQ, OQ is a nice, really easy one because it's already been given to us in the diagram as being just the vector Q. So OQ is Q. Now, what we technically have when we write Q is we really have one of them. We just don't tend to write the one in algebra. So we now have our two vectors that we can compare. We've got half of a Q and we've got a Q. If I factorise these, and I know it seems silly to do that, I can have half Q and I can have 1 Q, so I can then demonstrate that they share the same gradient, which is Q, just with different scalars.